Okay, let's connect the dots between drilling and driving. So for driver's ed today, we're going to talk a little bit about different types of fasteners and how we approach driving those differently. We're going to look at the correspondence between the drill bits and drivers and hardware. So let's start out by looking at the anatomy of screws in general. So this is what's generically referred to as a general purpose screw or a drywall screw, and it has what's called a bugle head. This is a flat head. It has a specific drive style, which is the Star or Phillips drive. It has a numerical designation as a size. This happens to be number 8 by 1.5 inches. So I'm going to, one thing to understand is that in general, when you're driving screws into wood, there has to be a space for that drill bit to be accommodated, because let's just say if I take a glass and I fill it full of water right up to the height of that glass of water, and then I try and drop some ice cubes in, that water is going to have to get displaced and it's going to spill out. And the same is very much true of when we're sinking fasteners into wood, because if there isn't an accommodation for the diameter of that fastener, then the wood has a tendency to split, especially when we're working out towards the end where the fibers are more prone to spread. So I'm going to take this extended length driver point, and I'm going to go ahead and chuck it up in my drill, and I'm going to go ahead and change my setting to one of the variable tension clutch settings on this, and I'm just going to have to take a guess at what's going to be the appropriate level of resistance on this clutch. And because I'm driving a relatively small diameter screw, I'm going to use the high speed setting. So I will make sure that there's a proper correspondence between the driver tip size is a number 2 that I'm using with a number 8 drywall screw. So I will position or secure the screw into the driver. I'll locate it onto my material, and again I'm forming a triangle, typically with the drill located over the top of my shoulder so that I have good downward pressure and good control. I'm going to start off using a slow speed until I establish that path, and then I can sink the screw down. Now you can see that I ended up burying the screw farther than I wanted to, and that's because the setting on the clutch was giving me too much force, and I want to minimize that force. So I'm going to try one more time. So let's back that screw out again, and let's turn that down to about 7 and see what happens. So once again, driving forward, good downward pressure, and here the clutch engages where we want it to, so the screw ends up mounted flush to the surface of our material. So I'm happy with that. If I'm am concerned with cracking or tearing to the fibers of the material, then I could use a conventional twist bit to drill my pilot hole, or again I can take advantage of the range of different options that are available out there for creating pilot holes, to be able to create a pilot hole and a countersink. So I've put in this fixed length number 8 by 3/4. I align it with my position. I drill till it mounts flush. I am now going to swap out back to my driver and mount my screw. And because it's a smaller screw, there's less load on that screw. I'm going to reduce the torque down to about 4 now, and let's see how that does. And again, nice flush mount to the surface of the material. So let's set that aside, and let's look at some other options in terms of driver points. We know that they come in a range of different sizes. So here we had a number 2. Here we've got a number 4. Here we've got a square drive in a number 1 and a number 2 size. Here we have what's called a spanner drive, which is used for security locks. And here we have what we call magnetic bit holders. So this allows us to be able to change out the different types of bits that we're using, and it lets us do that with a magnetic holder that also gives us the ability to hold on to that fastener hand-free. So that magnetic feature is very handy for keeping our bits in place. Let's take a quick minute to look at the fasteners that can be used to, or fasteners that we can drive with our cordless drill to make connections between metal to metal, or it could be leather to metal, or wood to metal, or rubber to metal. But the setup here is a small hinge that's attached to a piece of 2-inch square tubing. I went ahead and center punched locator holes because it is important for me that these holes be located exactly on center so that the fasteners sit properly. These particular fasteners that I'm using incorporate a built-in drill bit with self-cutting threads, and they come in a variety of different head styles. But what you'll typically find is with larger fasteners, they're generally going to have a hex head to drive them so that they have more purchase on the head of the screw and are less likely to cam out. But let's go ahead and chuck up this magnetic driver into our cordless drill. I'm going to be using this on a low speed setting to get maximum torque, and I really like the fact that I've got a magnetic bit holder here, because especially when it comes to short fasteners like this, I want to make sure and keep my hands free and be able to have 2 hands on the tool so that I can have good uniform downward pressure. If the clutch is not set correctly, then it's going to have a tendency to strip out the head of the screw, which is problematic if you ever have to remove that screw again. So again, remember to do a couple of tests to figure out what that proper clutch setting is. Let's go ahead and change out to the hex head driver. Set our clutch. Not only is it possible to strip out the head if the clutch is not set properly, but it will also strip out the internal threads that you've created as you've cut down in and into the cross-section of the material that you're attaching to. So self-drilling, self-tapping screws are incredibly useful fasteners for metal applications.